Okay, so sampling is very important for analysis of analytical chemistry. What is a sampling? Extraction of a small quantity of material from a large quantity the results indicates the whole material. Okay, result. So extraction of a small quantity of material from a large quantity, the results indicates the whole material. It is called as sampling. So what is extraction? Suppose for analysis, if you are prepared a 1 liter of NaOH solution, 1 liter of NaOH, basically it is a secondary standard. We want to standardize this 1 liter of solution. Then what we do? From this we take 10 ml in a conical flask, which is titrated with hydrochloric acid. After titration, we are going to calculate V1N1, V2 N2. So this indicates HCl, this indicates NaOH. Then N1 equal to V2 N2 by V1. Okay. So N1, for example, 0.0596 normal. Clear? This N1 value is 0.05961. Then for this volume of sample. How much volume you are taken? 10 ml. You are taken 10 ml. This N1 value is the representation of this 10 ml value. But this whole value, this concentration is represented to whole solution in our laboratory. We want to standardize this 1 liter of sodium hydroxide because it is a secondary standard. From this we take 10 ml only, or 3 or more times, 10 ml, each 10 ml, 3 times 30 ml. So for 10 ml the N1 value is 0.0469. Okay, this value represented this 10 ml. The concentration is considered as whole solution. So that as per the definition, extraction of a small quantity of material from a large quantity. So we take 10 ml from 1 liter and the results indicate the whole material. The results indicate the whole material. So this 0.05961, this indicates our 1 liter of the solution, that is sampling. Clear? Extraction of a small quantity of material from a large quantity, the results indicates the whole material, which is nothing but a sampling. Another example, semi-micro qualitative analysis. Semi-micro qualitative analysis. What is semi-micro qualitative analysis? Mixer. In your laboratory for inorganic analysis, we are given a mixer of cations and mixer of anions. From this mixer, we take a small quantity of sample in a micro test tube. Okay, add some inorganic acids for find out some anions, for find out some cations. In the same mixer, we are given a small quantity of material. From this small quantity of material, you are going to find out 3 cations, 3 anions, interfering radical, less familiar cation. All these factors are identified from your single sample. A small quantity of material, the small quantity results indicates enter your sample. That is sampling. Not only this, some other examples like volumetric instrumentation and like spectrophotometric analysis. We take a bulk solution. like nitrate, iron 3, iron 2. We take a small quantity of sample. From this, we are indicates the results of whole material. And the final example in our human body, we take a small quantity of blood sample for diagnosis. For this value, the doctor will be decided the diagnosis what type of diseases you have with the help of a small sample. That is sampling. So the sampling is most important predominant roles in our analytical chemistry concept. So what are the classifications? What type of nature of samples we are going to classify? Then we are going to classify basic phenomena. What is sampling? How it is classified? Where it is uses? Okay. For sampling, first one is collection of samples. First stage, collection of samples. For this, collection of samples conversion, because we have large quantities. Okay, collection of samples, conversion of samples, which is called as subsamples. Next, lab samples. Preparation of lab sample. So what is the role? First, collection of samples, because different type of samples having different methods for collection. Why? Because for solids having different methods, for liquids having different methods, for gases having some different method. So that which is called as collection of samples. And suppose we are going to collect a large quantity of samples like solids 200 kg, 300 kg, but we don't have methods for that much quantity of sample. We have a small quantity of sample analysis. How the large quantity of samples converted to small quantity, that is conversion of samples, which is called as subsamples. After that, before going to analysis, already we learned in a third semester. What is that? How the samples are soluble, dissolution, decomposition, how it is dissolved, how it is converted, how it is prepared, that is lab sample. That is lab sample. Suppose solids conversion into solution form. Suppose liquids, dilution. Suppose gases, conversion, because gases are pre-concentrated to liquids. So that is lab sample. Now we discuss about different type of samples, how it is converted, how it is analysis, what is basic need. So first, call it as grab sampling. Grab sampling. What is grab sampling? Suppose we have a large quantity of land. We have a square feet of land. We want to construct a building. Once the civil engineers approaches to our analytical chemistry people, we want to analyze the soil nature, how it is analyzed. Because we have the procedures, and the civil engineers are approaches to our analyst. Then our analysts are going to take a sample from a lab. How it is collected, how it is taken. So that first we take a sample from here, from here, from here. Because the columns are horizontal and vertical methods. First we take a sample here, one sample. So which is called as grab sample. Single sample is called it as grab sample. Single sample we call it as grab sample. Suppose here 1, 2, 3, 4, 5, 6, 7, 8, 9. All single samples are mixed to each other. All single samples are mixed to each other, which is called it as gross sampling. Which is called it as gross sample. A single sample is called as grab sample. All samples are mixed to each other is called as gross sampling. Why? Because for the square feet of land, we take a different type of samples, different areas of samples. Suppose first we take one sample. After that, we are going to take 1 feet length depth. Again, we take a samples. All samples are mixed to each other. That is gross sample. Only single sample is grab sample. That is difference between gross sampling and the grab sampling, which are very, very important. And the most important example in our Visakhapatnam, we have a steel plant. What is steel plant? What is the raw material? Iron ore. In third semester, we are learning more about iron ores. How many of constituents present? 15 to 17 components are present in iron ore. So the samples are collected from where? It is the ores, mines. In steel plant, the samples are coming for wagons, a big large container of train. If it is suitable for making of iron rods or not suitable of iron rods, how you know this? After getting the raw material, we are going to analyze. So before going to analyze, how you are collect the samples? Because one wagon having a container having the depth from high level to low level. Then how you are collect the sample? We have suppose 30 boxes of materials, 24 boxes of materials. Containers is large quantity. Then how you are collecting? So that we are going to, another formula is random sampling. So we are going to take a sample in a randomized containers. Okay. So all these are okay. But as per the first definition, what is the definition? Extraction of a small quantity of material from a large quantity, the results indicates the whole material. When it is possible, that is very, very important for a sampling. When it is possible, our definition is concluded basing on the sample must be homogeneous. It is very important for analysis. The sample must be homogeneous. If it is non-homogeneous, our definition will not be valid. If it is homogeneous, our definition will be valid. What is definition? Extraction nothing but any type of analysis. Okay, like volumetric, instrumental, gravimetric, instantaneous methods. Extraction nothing but any type of analysis from small quantity of material from a large quantity. But the sample must be homogeneous. That is important condition. Okay. So grab sampling, gross sampling, for random sampling, these are the different type of sampling procedures. Then we are discuss about classification of sampling. The most important is solids, liquids, gaseous. Three different type of samples: solid samples, liquid samples, gaseous samples. Solid samples, basically we have some components. Stones. Tell me about some solid samples. Crystals, ores and minerals, sheets, wires, stones, crystals, ores, minerals, sheets, wires. These are all solid in nature. Sheets nothing but iron sheets, wood sheets, and wires, iron wires, copper wires. These are all solid in nature. So all these are solid in nature. Mostly cases ores and minerals, mines, coals, Coal. Coal is a solid sample. Coal mines. Coal mines. These are all solid in nature. For liquids, these are two types. Homogeneous liquids heterogeneous liquids. Homogeneous liquids, heterogeneous liquids. Two different nature of liquid sample, homogeneous and heterogeneous. So what are the homogeneous? The best example for homogeneous is river water. River water is the best example for homogeneous. Heterogeneous, like the best example of heterogeneous, lakes, streams, reservoirs,
ponds,
ponds, all these are gaseous. Online, instantaneous, monitoring methods. Online, instantaneous monitoring methods and pre-concentration. These are all the methods for a collection of samples and as well as nature of samples. So now we discuss how the solid samples are collected, how it is converted from large quantity to small quantity, and liquids for homogeneous liquids and heterogeneous liquids, and gaseous for pre-concentration and online instantaneous monitoring methods. These are all the different nature of solid sample. So the classification of samplings. Okay. So now we are discuss about solids. How the solid samples are collected, where it is collected, and how it is converted from large quantity to small quantity of the samples. Okay. Solids. Solids. For a small example of seeds. How the seeds contain some nature of sample. The seed's thickness is low. How it is checked? Before going to that, we want to collect the sample. The seeds are different shape. Okay, which is seeds. First, we take a sample from here with the help of cutter, and then here, then here, and then here with the help of cutters. Then take another piece. Okay, so this from here, from here, from here. Again, we take another 1, 2, 3, 4. So from this, we take small pieces of different areas from starting area to middle of the area of sheet. We take a different sample. Single sample is grab sample. Collection of all the samples are gross sample. First one is collection of sample. Our criteria, that is gross and grab sample. For this sheets, why we are going to from here to here? Suppose in our home we want to prepare a chapati. Okay, from rolling. From starting to ending, it is in homogeneous, it is in the same shape, it is not in the same shape. If it is in a machinery, there is a same shape. In our home, it is not and happens. Ante kada. Middle of thickness takku untadi, bottom lo ekku untadi, ikkada homogeneous untadi. Ante. Close chesi